Hello everyone, my name is AMARTYAYA and today I'll be talking about my 8085 microprocessor project, which is the pseudo random sequence generator using LED matrix. Let's begin. First I'll start by giving you an overview of the project. In this project, I have an 8085 microprocessor kit that is connected to an LED matrix kit. The LED matrix is configured to display the letters A, B and C. Now a seed is given to the program at the address 3000. Next, depending on the value of the seed, a particular order is chosen and the letters are displayed in that particular order. So what that means is, let's say for example my seed is 6. Then the sequence that may be displayed may be, let's say, A, B, C. Now if I change the value of that seed, let's say to 10 or 8, then the sequence will also change. Now it may be, let's say, B, A, C, or maybe it might change to C, A, B, or whatever we choose. So first I'll start by giving you the pseudo code of the project so that you understand what's happening at a high level. So first we'll start by initializing all the ports so that everything works as expected. Next we'll get the value of the seed from the memory location 3000H as was discussed earlier. Now consider what we're actually doing. Well, the idea is that we have these three characters A, B and C, and what we want to do is we want to get a particular permutation of A, B and C. So what is the total number of permutations of A, B and C? Well, it's 3 factorial or 6. So depending on a particular value of seed, we want to get one of 6 unique values. So how do we get that? Well, one way to do that is to calculate the modulus of seed with respect to 6. Here percentage stands for modulus. So we calculate 6 seed mod 6, and this gives us a unique value out of 6 unique values. We get one value out of 6 unique values. Next, we can get that unique value and put it into the permutation table, and the permutation table will give us this unique sequence that we want, that is associated with the unique number. So now that we have a unique sequence, we can use that sequence to display using a bunch of for loops. Now this for loop is to iterate through all the columns of the LED matrix, and also to introduce some short delays for persistence of vision. So first we'll start by talking about the initialization. So in the initialization, we'll first start by initializing everything, so that we'll initialize all the ports and we'll initialize the 8255. Next, we'll load the seed byte into the accumulator A. So the seed byte was stored in the 3000H memory location, and this will be loaded into the accumulator A. Next, we'll evaluate the seed. So as you remember, we'll have to calculate the modulus of seed with respect to 6. Now, because the microprocessor doesn't have any division operation, we'll simply keep on subtracting 6 as for division. So we'll keep on subtracting 6 until it becomes lesser than 6. So this will replicate the modulus operation. Now, if the remainder becomes 0, then we can simply use the mod done loop, or if our remainder is actually not 0, if it's some value between 1 to 5, then we'll use the mod carry loop. So the mod loop here simply is just a jump so that we get a for loop out of this. So once the modulus calculation is done, we now refer to the permutation table. So what is the permutation table? The permutation table is all the hard-coded values of the sequences. So you can think of the permutation table as a matrix in which the matrix has 3 rows which stand for the 3 characters A, B and C, or it can be B, C, A or C, A, B or whatever. And it has 6 columns. So it has 6 possible, for all the 6 possible sequences, it will store the 3 characters. So it's a 6 cross 3 matrix. Because it's 6 cross 3, we'll need an offset. So the offset can simply be used the offset can be simply obtained by multiplying index and 3. Um, so that's one of the advantages we get by using the mod operation. Next, you simply add this offset to 20h. What is 20h? Well, the first byte of the permutation matrix is actually 2120h. So if we simply add 20h to the offset that we get, we'll simply get the starting character of the intended sequence. Then, because we actually want a full 2120 or 21xxh, then we'll simply store the 21h as the higher pointer, and the whatever is stored in A into the lower pointer. And now what we get is that the starting pointer of the sequence is stored in the HL register. Next, we'll talk about the display loops. So the display loops is um, are simply the loops that we use to display the characters on the LED matrix from the intended seed that we get. So the first one is loop 4. The loop 4 is the infinite loop. This makes sure that the sequence gets to be displayed an infinite number of times. Then we have loop 3. The loop 3 simply just iterates over the characters. So let's say the sequence that we have is A, B, C. Then it will iterate over A, B, and C. Now next we have loop 2. The loop 2 is simply make sure that each of the characters is displayed a long enough time so that we have that persistence of vision we talked about before. The loop actually goes over for FFH number of times, which is 255 number of times. So for 255 number of times, each of the characters will be shown so that we actually somehow get we actually seem to get a persistence of vision, because the microprocessor is very quick and we want to actually see the value. We actually want to see the graphic on the LED matrix for a long time. Finally, we have loop 1. The loop 1 iterates through all the columns of the LED matrix, and so this helps us to actually individually show what the value in the column is, so that we can actually show that on the LED matrix. Now loop 1 also has loop 5. The loop 5 is just a delay. So what the delay does is it actually delays the column, so that the column is shown for a long enough time for the persistence of vision. So if you actually pay attention, we actually have two delays. We have the FFH delay, or the 255 number delay, which is loop 2, and we have a loop 5, which is an additional delay that we put into it, so that we actually can see the graphic on the LED matrix for a long time. Finally, I'll wrap it up by talking about the data section. So because we want to show the characters A, B, and C on the LED matrix, we'll store these values in 2100H, 2108H, and 2110H. So all the memory addresses from 2100 to 2118 will actually contain the values of A, B, and C, so that they can be displayed on the LED matrix. And from 2120 to 212F is the permutation matrix. So if, let's say, our seed is 0, we will show the sequence ABC. If our seed is 1, then we'll show CAB. Now let's say our seed is bigger than, let's say, 5, so let's say it's 7. Then we'll simply calculate 7 mod 6, so seed mod 6, which will give us entry 1, and we'll get the output CAB. So this is the results section. So I'll show you what I did. So in here I'm entering the seed to be 8, as you can see, and because it's the 8 mod 6, we'll simply get, as we'll see here, we'll get DCA as the sequence. So this will continue showing DCA for an infinite number of time, and since I pressed the reset button, it stopped. Now you can see here. Here I'll enter the seed 01, and 01 will show us this sequence, which is simply CAB. So it will continue showing us CAB for a infinite time. So that's my property. Okay, so that's the end. Thank you for watching.